Assalamualaikum and salam sejahtera. We are from UITM Shah Alam. We're going to present about our education research, which is high resolution optical temperature sensor. So for introduction, FPG temperature is designed and simulated based on optical frequency domain photometer. The overall temperature system is designed using OptiSystem software. FPG sensor is designed by using optigraphic software. A continuous wave laser is used as the optical source and is transmitted into FPG. The two FPG reflection spectra will produce a frequency that can be detected as using a RF spectrum analyzer. Any temperature change will shift a bright wavelength. So in this work, an FPG with temperature sensitivity 14.4 picometer per Celsius is employed. It is found that by using this technique, a high resolution temperature sensor can be designed with the highest temperature resolution of 0.1 Celsius. Problem statement. High cost optical spectrum analyzer to observe the shift of a FPG reflection spectrum. 2. FPG variation with a low resolution exhibit limited ability to differentiate closely spaced wavelength, which can result in several drawbacks. And third, the limited dynamic range may restrict their use in scenarios requiring analysis across a wide range of wavelength, and frequency crosstalk can cause interference and inaccuracies in measurements. So our objective is first to design and develop high resolution to continuous and low cost FPG temperature sensor based on OFDR to simulate and analyze the most optimal performance of FPG temperature sensor, and last is to analyze the performance of the FPG temperature sensor. For simulation setup, the setup for the FPG sensor system will demonstrate, which includes CW laser source, 2 power splitter, 4 FPG, RPM .5 amplifier, photodetector beam, and RS spectrum analyzer. The simulation is performed using OptiSystem software. 4 FPG are employed in the sensing system. FPG1 and FPG2 act as the reference arm. FPG3 is fixed, and for FPG4 is import from optigrating with various temperature change. In the optigrating, the FPG4 is designed as temperature sensor, and the temperature is adjusted to observe the bright wavelength shift. So figure 1 is a OptiSystem simulation, and figure 2 is reflected and transmitted spectrum of FPG with a bright length of 1550 nanometer. Reflected spectrum is represented by blue line, and transmitted spectrum is represented by red line. For result and discussion, figure 3 is for temperature change at 0.1 Celsius, figure 4 is temperature change at 0.2 Celsius, and figure 5 temperature change at 0.3 Celsius, and figure 6 temperature change at 0.4 Celsius, and last is figure 7 temperature change at 0.5 Celsius. As we can see, the best resolution is a temperature change at 0.1 Celsius. For figure 8, theoretically every 0.2 Celsius temperature change will cause a bright wavelength shift of 0.003 nanometer. For the simulation, every 0.2 Celsius temperature change 0.004 nanometer bright wavelength shift is shifted. So next is for figure 9 is every 0.1 Celsius temperature change will produce a frequency change of 0.19 GHz. For the simulation, every 0.1 Celsius temperature change, there will be a frequency shift of 0.25 GHz. And for figure 10 is the higher the value of a temperature change, the bigger spacing between frequency. For the theory, every 0.5 Celsius temperature change will cause a 0.94 GHz frequency spacing. For simulation, every 0.5 Celsius temperature change, 1.25 GHz frequency spacing will be observed. So for application, we are more focused on continuous temperature monitoring for human body. The FPG sensor is capable to monitor human body temperature. It continuously measures the wavelength shift in a response to temperature change. The data from the RF spectrum analyzer need to be processed to convert the wavelength shift into temperature readings. So next is the real-time continuous and high-resolution temperature sensor will allow continuous temperature monitoring for human body, especially amongst babies, kids with the lowest resolution of 0.1 degrees Celsius. So for another potential application is aerospace and aviation. FPG sensors are employed in aircraft, spacecraft, and satellite to monitor structural health, vibration, temperature, and pressure, contributing to maintaining efficiency and flight safety. And next is automotive industry. In automotive application, FPG sensor can monitor the structural integrity of vehicle, engine component, and other critical parts, contributing to safety and performance. And lastly is for the conclusion, FPG temperature sensor based on OFDR has been successfully demonstrated and simulated using OptiSystem and OptiGraph software. Using OptiGraph and OptiSystem software, FPG is designed as temperature sensor. The break wavelength will fluctuate with any change in temperature values. The temperature system is simulated and is capable to detect temperature variation of 0.1, 0.3, 0.2, 0.4, and 0.5 Celsius. The simulation result proved that temperature sensor with the highest temperature resolution of 0.1 Celsius can be perceived using an RF spectrum analyzer. That's all from me. Thank you.